For 920, our drawing space will be a little bit more limited because this entire height will not allow us to draw underneath here. So I'm just going to draw a construction line showing you what I mean. My drawing essentially can't pass this line. So our paper is going to change its size for our spacing on this one. I'm going to measure my horizontal distance, and I really only have 7 3/8 to work with. My height stays the same, so I have 6.5 by 7 3/8, which is 3, 2, 5. Just do 3/8. All right. So when I space this out, I'm just going to give myself 1/4 inch spaces from left to right, then the middle space, and then the right side view. The front view is going to be a circle, and we're dealing with a cylinder here, so the height is going to be one of those views that we don't need, because remember, we're only drawing the necessary views to describe this object. The height and the side are essentially going to be the same thing. So to center this, my vertical spacing is going to be fairly easy. I'm just going to find the middle of 6.5, 3.125, and this is going to be my center line. So I'll just draw a construction line on it for now. Then my spacing, I said, is going to be 1/4 inch. Let's go ahead and figure out our height. The height of this thing, you have to basically follow the extension lines to understand what we're looking at. Some of the dimensions don't actually go all the way through because we see this section view. This section view is not actually going to be drawn in our multi-views. It's not going to be drawn in our front or our right side. This is theoretical. It's only cut in the isometric so we can understand the interior details of this thing. So this 4.75 diameter, starting from the top, and it goes all the way to the bottom. So our height is 4.75, and so is our width. Our depth from front to back, we have to calculate. So if you see this 1, it's showing us from this surface of the front small cylinder to where it connects to the bigger cylinder is 1 inch. Then we have to figure out the depth of this larger back surface, which is right here. It's saying that from this to this is 1 inch. So 1 plus 1, that is 2 inches. All right, so overall we're gonna have 4.75, that 1/4 inch gap, and then 2 inches. So let's go ahead and box that in. So 4.75 from our 1/4 inch space is here. We're gonna have another 1/4 inch space, and then our 2 inch depth. And you can see it's really close to giving us that gap. I had already kind of figured out that 1/4 inch spacing, that's why I gave it to you. All right, now to start, I could box this in, but I know that the front view is going to be a circle, so I'm going to jump right to drawing a center line and using my compass. So if my diameter is 4.75, that means I need to divide that by 2. So half of 4.75 is 2 3/8. So now I can draw small dash, long dash, long dash, grab my triangle, and draw my vertical center line. Small dash, long dash, long dash. Since I've already measured this on my paper, I can really set my radius to the measurement I've already created. So this circle is also going to be my height. Let's project this over. And I'm going to box in my right side view. So construction lines, because I don't know exactly what the shape looks like yet. And I'll just clean that up. That line I'm erasing right now, that is just from where I wanted to stop my drawing. All right, now looking at this, I know that in front view, I have a bunch of circles, right? I have this small interior circle, I have the outer edge of it, so that first one's 1.25, then the second one, and then what else does all this mean? Well, I see these little tiny circles, and this 3.5 represents the diameter of the orbit that those circles exist on. So if I draw a construction circle at 3.5, I know that there's going to be 4x means there's 4 of these on this diameter. Now each of these small diameters are actually 0.312, and the EQSP means they're equally spaced. So that means on that orbit, I'm going to have 4 circles. Well, if you take a circle and divide it by 4, you know that it's every 90 degrees. Just so happens that they are going to fall right on my center line, so that's going to be pretty easy. This next diameter, 4.25, is actually representing this hidden edge that we can't see. We can see it from the back view, but from front view, we can't see it. That means we're going to have a hidden line or a hidden circle at 4.25 diameter. So I'm going to just start my front view by drawing a bunch of diameters. I'll just start from the smallest and work my way to the biggest. Don't forget, some of these are construction, and then some are going to be hidden. So instead of drawing the whole thing, just be aware of that so you can save yourself some time and erasing later. We are using a compass, so we have to divide each of these to figure out our radius. So 1.25 is going to be 5/8. Alright, now that I have all my circles drawn in front view, I can now project this information. I'm going to visualize ahead to understand what I actually need. I have a couple depth dimensions that I have to consider when working in this orientation in right side view, because remember, this is front surface, back surface, so this is actually depth, not width. So this is depth, this is height. Heights are already established in front view, so I can project all heights over and measure working from left to right. So I know first that this big cylinder is going to be a visual edge. So I can project this surface, because that's the outer surface, over, and it's going to come back 1 inch. Now I know the front surface, this is again a theoretical section view, so it's not actually there. So that's going to be an object line. Now this front plane is circular, so it's actually going to come in front of this little cylinder and be one object line from the entire from the extent of the height. So from the very bottom all the way to the top. The back edge, while I'm here, I'm going to make this an object line as well. And then the bottom and the top of this will also be object lines. So I'm going to remove some of these construction lines so this isn't as confusing. Normally I would just wait till the end to do this. So this is the outline of our right side view. However, there's a lot going on the inside. That's why there's this little section view. So this hidden line represents this edge, but it doesn't go all the way through. It starts, well, if you look here, 0.75 from the back edge. So if I project this over, I'm going to create a hidden line that's 0.75 off the back. Then it shifts directions. It goes straight down, representing this thickness right here. That thickness is 0.25 because I know that this entire thing is 1 and this is 0.75, so the remainder is just 0.25. So the wall of this surface is 0.25 thick. It comes down and then goes left towards this surface, which I can project this surface over, which gives me this thickness of basically this pipe that's attached to the front of this flange. So I can project this over. It's going to come in as a hidden line until it intersects that 0.25 line. Now that 0.25 line is really in 3 dimension. So let me just start drawing that, and then we'll discuss where it actually goes. All right, this is 0.75 off the back, so right there. Now, most of the time I see students draw it like this. The problem with this is that means that this wall, this thickness right here, stops. We know that it goes around this contour. Let's jump to the 3D model. So this is the right side view of our object. As you rotate around, this is what the isometric view would look like. Now let's rotate around to see the back view. Now you can see that inside surface of what we depicted as a hidden circle. Alright, so that hidden line that we drew as a circle is really this interior surface and this edge. As we rotate around, you can see those 4 holes and also the center hole that goes all the way through. Now, let's cut this thing in half. You can see the interior details and what we started drawing as our hidden line off the back surface. That 0.75 hidden line that comes in here and then starts going downwards and meets this hole that comes in as another hidden line. However, it doesn't stop there because the hidden line also depicts not just that edge, but this entire surface that you can't see. If you see a surface in edge view, that also appears as a line, but since we can't see it, as it rotates around and aligns up, it becomes a single hidden line that goes all the way from this thickness of the wall, starting here, comes all the way down until the opposite side. So after looking at that, I know that this hidden line should continue because this wall goes around the entire cylinder. So now I have my hidden lines, and last are these small holes. Now they go right through this wall, and now that I have my hidden line, I know that they start from this front surface and just pass through. They don't continue to go all the way to the back because this is hollow. There's nothing there. So you can't have a hole in space. All right, it has to be a hole in mass or material. So when I project these over, I have to get really small with my hidden lines because I only have this small space to work within. So I can fit 3 small dashes in there. I might have to adjust my hidden lines on this back edge because they should touch. I'll do the bottom and top. And these two align, so you're really only going to see one in the middle, right through here. So without front view, and you only had right side view, it only looked like there's 3 holes here, but this front view shows us, okay, there's 4. So this is a little confusing in right side view, and that is why it's essential to have all your multi-views to communicate this. Lastly, I need some center lines. So this is a cylinder. That means this big center line would continue over. I'm going to do a long dash, small dash here, long dash. I'm going to do a little small dash